Hello everyone, my name is Stas and this is my Raymarching in TouchDesigner tutorial, part 1. Raymarching is a rendering technique that's a bit different from ray tracing or raycasting, and it's really good for producing a smooth combine primitive objects like here or like here, and it can be pretty computational efficient because I run it in 60 FPS and it's easy and I can increase number of spheres. It's also very good for making fractals, but it wouldn't be covered in this part, maybe next time. I wouldn't go too deep into theory of Raymarching because there is a very nice video. It's called Coding Adventure Raymarching from Sebastian Lake, and I really recommend you to watch it and even watch it before this tutorial, because it's just 5 minutes and it gives you enough theory to understand what's going on. So please, let's do it now. Okay, welcome back. I hope you saw this video. And also you need to download the example files. It's in my GitHub repository called Raymarching in TouchDesigner, and I put the link both to this nice video and to my GitHub below. And we will work mostly with tutorial part 1 too. So if you open this, you'll see several containers, and let's start from the basic setup. My goal in TouchDesigner and Raymarching is to do as much as possible inside the parameters of TouchDesigner itself. But Raymarching, it's only possible inside GLSL code, and you need to understand GLSL at least a little bit to make it work. But the many parameters actually can be changed here. For example, here is the color and the color of a light you can change, and the camera and many other, and the Raymarching parameter itself, which I'll talk a bit later. And the code itself, let's view it. And by the way, I really recommend you to use some external editor. For example, I'm using Sublime Text because you really need highlighted syntax to efficiently coding. This code is based on tutorial from Jamie Wong about Raymarching. This tutorial is made for ShaderToy, so the code is a little bit different, but it's also very nice math and nice explanation how it works, and I recommend you to follow this tutorial, but not on ShaderToy, but in this TouchDesigner interface. And I leave a lot of Jamie Wong comments and put some mine comments as well, so I hope you understand how it works. What else? This part of tutorial mostly would be about the scene setup, and this part here, because it's I would say it's only part that you really need to write a code, because the rest of the code is a Raymarching algorithm itself, which you didn't need to change most of the time, for at least for simple setups. Then it's light and coloring, which can be changed here, as I said before. And the only thing you need to code is the geometry itself, because there is an endless possibility of how you can do it, what you want. Is it a cube or sphere or a lot of cubes or noises, and how it's combined, or maybe you need the fractals. So it's almost impossible to make a good visual interface for this. That's why the part 1 of tutorial is about the scene setup and how to code it. So we will focus on this short part of the code. But actually, let's go to the second container, which called the primitives. Because what is stage? What I call the stage or a scene? It's a part where you describe geometry. So it's the primitive itself and the way how you combined it. And as you can see, here I have a little bit different setup. And the GLSL code itself, it's made inside the merge dot that consists of 3 another dots. Here we have a first part of the code. You don't really need to look at this now. This is the second part, which about the scene, we will focus on that, and this is the third part. And I did it also because it's one way of how you can switch between different Raymarching scene. For example, I can go 0, 1, scene 1, scene 2, scene 3, and so on. Let's start from scene 1. And let's open this code. It's Ctrl E. This is super simple scene. It's just a single sphere. What you need to understand is the Raymarching algorithm would need from you this function called scene SDF. SDF is sign distance function. And as input, it takes only one parameter. It's a P. It's where are you now? Let's say where your Raymarching algorithm right now, and it returns a float that say how far are you from any surface, a surface of any object. So it returns only one number, a float. If it's negative, that it means that you're inside something. If it's positive, then you're outside. And the Raymarching algorithm would draw everything outside as empty. You can see it here, and everything that inside, or let's say on the surface of the object, with some color, which the color described here with ambient, diffuse, specular, and the color of the light. You can change the color of the light to see it better. So, how it works. Inside this scene, you will need to put the primitive you want. And it could be really hard if you need to figure out it by yourself, but there is a very nice page from GLSL, which has a lot of helper function about different type of primitive sphere, boxes, round boxes, and so on and so on and so on. So you can just copy and paste it inside the code. Another great resource is this Mercury HG SDF. SDF is sign distance function. I actually prefer GLSL option because I have some issues with this library, especially this intersection didn't work for me, this a pipe didn't work for me. I don't know why. And actually I'm exploring Raymarching only about 2 months, so I'm not a really good expert on this topic, but I hope I can clarify something for you. and make your journey into Raymarching a bit easier. So, for example, sphere. We have a sphere, we have a function for sphere, and we put it into our code here, sphere. And for creating sphere, you need just the two parameters: the point, the center point where a sphere would be created, and the float, which says a radius of a sphere. And here I have, and when I describe my scene, I say, okay, create a sphere on a center point with a radius equals 3. Or I can say equals 2, and sphere becomes a bit smaller. Super simple, nothing interesting. So let's move on to second scene. A box. I wouldn't go through every primitive, and actually I don't have example for every primitive because it's I don't see a point for doing this. I want to show you some tools that you can use. For example, for a box, let me change the syntax. For a box you need, as an input of a box, you need vector 3, which means vector 3 contains the three numbers, X, Y, Z, or RGB, or STP, it doesn't matter, and another vector 3. And I know this second vector 3 is the size of a box, so it's dimension on every three directions. So I need to describe it in my scene, and I create a new variable called vector3 size, and I put the desired size of a box here. I can again change it to show you it's changed. But as you can see, my box created not in the center, and this is because these three lines. Let me comment it. So here is in the center, and this is a really confusing way if you get used to TouchDesigner and normal rendering technique, because usually you create a box and then you move a box itself. But here with Raymarching you need to do something different. You need, because the box itself, it's not a three-dimensional object, it's just a float. As you can, it's a float that says, are you inside the box or are you outside the box? So you can really rotate a one-dimensional variable. And instead of this, you need to do something with, let's say, a space itself. So you warp in a space, you change an original point, you change the center of a scene, and then you create a box in this new central point. It would be easier to show it. For example, from Raymarching algorithm I have the point where I'm now, and I say, okay, move this point a little bit, 2 points on X, 1 point on Y, and 0 on Z dimension, and the box moved. And then I say, okay, and also rotate the space a little bit. And for rotation you can use the TouchDesigner built-in function called tdrotate. It's tdrotate X, tdrotate Y, and tdrotate Z. And you need to pass the radians, how much you need to turn it, and if you prefer to think in degrees, you say radians and the number. For example, here is a 45 degrees, and I can change it to 90, and it's rotated 90 degrees or 60. And the same with another direction. in Y, or I can change it to a Z. And after you do all transformation you want for this original point, original space, I'm not sure how it's better to think about it, but you will get used to it after you will experiment with Raymarching. So after you transform your space, you create a box. You create a box and give this new position variable and a size, and I describe size here. And you return a sen, and Raymarching algorithm do everything else for you. Okay. Let's move to the next example. Okay, capsule. Let's see what we have here. Yeah, there were one not really convenient thing is on this side. If you look for a capsule, it just gives you a function, but didn't explain what means vec3 A, vec3 B, and float R. So you need to experiment with it by yourself and understand what does it mean. I did it already, and I know this vector 3p is a position as always. This would be one side of a capsule, this would be another side of a capsule, and this would be a radius. And I do a hard-coded version of sides. So one side it would be moved minus 0, 1, minus 0, 1, minus 0, 1 in every direction from a central point, and the second end would be moved a positive 1 for every direction. By the way, if you put only one number but it's vec3, it interprets this as vec3 1 1 1, and of course you can change it again. Oops. Can change it again. But what I want to show you here in this example is that you can use actually dynamic variables. Here in my GLSL top, I have a parameter called uTime. I did it by myself. I just type uType, or I can show you differently. Okay, uTime, and this is me-time seconds, which is it's almost the same as EPS time seconds, but it's for this current timeline. And I want to pass it into my code. So first of all, I need to say the GLSL that I have this variable, and I do it in the first part of the code. And here I set a uniform float uTime, because it's float because it's only one value. Uniform float uTime, and then I can reference this uTime anywhere else in my code. And here I referenced it in rotation. So the way the capsule rotated, it's always rotated on this radians, both on x and y direction. And the float radius, it's again hard-coded. But of course you can say the radius would be uTime, but uTime is too big, so let's say uTime multiply by 1. Yeah. Okay, it's not very visible, so it goes bigger, bigger, and bigger. As the uTime goes bigger, this also goes bigger. Okay, I hope you understand this part as well. And yeah, and in the end, you need to return this float as capsule. you can alright, I'll show it next time. Let's move. What next is okay. Number 3. Number 3. Yeah, sometimes the code is written, but the primitive itself, it's really hard to understand. But you know what? You don't need to understand how is it constructed. It's some difficult math. But maybe as a puzzle, as a task for yourself, you can try to understand what's going on and why this function works as it works. And again, I explain to you one more time that this function is return the only one number, which can be, for example, -2 or plus 10 or something. And this number says how far are you now from your current point to the primitive. So, oh yeah, here I just want you to show that you can use trigonometric function in GLSL. So you just type sinus, you time, and because the sinuses always return the value between -1 and 1, it moves, it actually scales bigger and slower and bigger and slower. Okay, next example. Number 4. Oh, okay, this is a good one. This is actually a torus, but you inside this torus. Raymarching, it's connected with is called SDF, or sign distance function. This function is that will return this number of distance, and it's called signed distance because it has a sign. If you get a result with minus sign, it means that you inside some primitive. And the Raymarching algorithm would know that if you get minus something, that means that you hit the surface, so you need to color it as a surface. So if I return normally like I did in previous example, I will get just everything purple. Why is that? Because everything is a surface now, because my camera is where is my camera? My camera is 10 units from a center, and the torus itself has a radius of 11. So the sign functions give me -1 or something. Here's I also have rotation, so it's not -1, but okay, let's say it's -1. And because it's -1, it means that I already hit the surface, so everything is the surface. And Raymarching paint everything with single color, except for light and normals, but okay, single color. But if I want to show you what inside a torus, I need to put minus here. So minus multiplied by minus would be a plus again, and here the Raymarching would okay, sorry. The Raymarching would wait until you hit the next surface. So instead the Raymarching would wait until you hit the surface of the object. It will wait until you hit the surface of the object from inside. I hope it's at least a little bit clear. But just experiment with this and you'll get it. I hope. Or ask in the comments and I'll try to understand it. I'll try to describe it more clearly. Anyway, and as I said, sometimes it's really weird and complex function. Here is one of my favorites. It's is a surface from Alex Kluchikov, and it's described like here, and I'm not sure that anyone without a really good math understanding could understand what's going on here. But you don't need to understand it to experiment with it. For example, you can change some number and oh, it doesn't work. Okay, it doesn't work. What if I change something here, for example? Oh, okay, interesting. Okay, maybe 10 is good. Okay, maybe 20. Oh yeah, another interesting option. And this is here I have a hard-coded number, but of course you can put a variable here and run and move this number by some chop from audio or from Kinect or lip motion or whatever. Okay, this is a primitive section, but now let's move into combinations, because usually one primitive is not enough. You need several primitives, and when you have several primitives you need to combine it somehow, because again the scene always return only one number. So you can so even if you have 1, 2, 3, 4, 5, 6, 7 objects, you still need to combine it somehow. Combine it into one number. Okay. And again, this is described here on Inigo Quilez's page. Down below here. Here's the primitive combinations. How to combine things? First you need to create these things. Rotate a space again. I can comment this to show how it was. Okay, this unrotated space. And yeah, I unrotate this as well. Okay, this unrotated space. I create a new variable called move left, and here I have move right, and I pass a variable called udist. U stands for uniform dist, which is vector 2, and it says how far you move from in x direction and in y direction for a primitive. And I have a hard-coded number 3. You can of course it moved to 4, and here I have y direction, which goes like this. And what we have? We created a box, this one box, then we created a sphere, and then we'll use one of a combination function. For example, here on the left I have the smooth union between this left sphere and this left box. And this function also need two floats, which is our primitives, let's say box and a sphere. But of course it could be anything. It could be two spheres, or this some crazy is a surface and another crazy is a surface. And the floor, and the third one is a smooth coefficient, and it's also described here. And if I change the smooth coefficient, it would be a more smooth or a less. If it's 0, if it's set to 0, it would be equals to this example. I change dynamically again. So, where am I? So here I created the union on the left side. Is kind of the same in the center, but I don't need to move it to the left or to right. It's in the center, so I just pass a central point. And here on the upper row I have example for repetition. Actually, the repetition, it's mostly used for creating a fractals, because the fractals, it's very popular it's very popular to do a fractals using Raymarching, because it's very efficient and you can create 3D fractals almost real time, most of the time. But I wouldn't go too deep about repetition, because it's a really complex topic, and we will need another, I don't know, couple hours to explain how to create fractals. So here is just example for you, and you can use this example and try to modify it and to see how it's changed, and read this one here and understand by yourself. Let's say. But again, now we have this, let's say, 4 objects. This union, this subtraction, and this intersection, and this repetition. And we need to combine these 3 as well in the final scene, because, as I said many times, in the ending we need just only one float scene. And we create a scene, and we just union the first one with the second one with a smooth radius equals 0. Then we add a third one and the fourth one, and return it into our Raymarching algorithm. Okay, this is it for our basic way of creating the scene. And if you look at GitHub again, you have this template basic tool. It's open here. So let's try to create some simple example. You open GLSL code, you move it, you open parameters. So let's do something really stupid and simple. We need to describe a scene. Okay, I'll delete this, I'll delete this. What I wanted to do is to create, let's say, 2... Okay, let it be simple. Let's create 2 spheres, because it's really fast. Spheres, we need spheres, so I put a code for sphere, and I would like to union it to spheres, so I look for a code for a union. Where is my union? Union, smooth union, here. And let's start. Okay, let's create 2 spheres. 2 spheres. and I call it float sphere 1 is the sphere, and we need to pass it the position and the radius. And I don't want to hard code it, so instead in my vectors page here I can use a vector 3 for example, or vector 1, any page. I create the new variables uSphere 1 and uSphere 2. Yeah. And it would say how far you need to move it from origin. And after I add it here, I also need to add it here as well. So I put it uniform. It would be vec. Oh, actually, it would be vec 4, and I explain you later why vec 4, not vec 3. It's called USP1 and SP2. Look here, we need position and the radius, so I can put the radius here as well. So the only thing now I need to say to vec. Well, actually, I don't need to put it vec 3. I just can USP1 XYZ. So it's the first 3 numbers. And the radius is the USP1 W. Or it could be, I could use RGBA, doesn't matter. It's a syntax of GLSL. You can find the details about syntax somewhere else. And I repeat it for the I repeat it for sphere number 2, sphere 2, sphere 2, sphere 2, and let's combine our spheres. Let's call new variable C. Oh, I used since somewhere before. Oh, okay. Let's put it sphere. So it's smooth union between sphere 1, sphere 2, and for smooth union I also need this float K, which is smooth radius. Do I have it here? No, I don't have it here. Okay, I just say it's hard-coded to 1, and I return a scene. Let's see, what do we have? Okay, we have some something. Declaration conflicts with previous declaration, undefined variable. Let's see. Oh, okay. I have 2 sphere 1. Oh, now it works. Now it works, and I don't have anything because maybe it's too far away. No? No. Okay, let me think a moment. Alright, I got it. It was a really interesting mistake, and we can learn from it. Look, here I describe the position of a sphere only from this variable, but actually always I need position not absolute, in absolute values, but relative to the point where we now. It's called p, relative from a p. So you need to, from the central point of a space. So you need to p minus, and now we have our sphere. We have only one sphere because it's kind of close to each other. And let's make it a bit smaller. Let's make it a bit smaller. As you can see, it's moved away from each other, and let's say it minus, I don't know, 0, 5, 0, 5, 0, 5, 0, 5, 0, 5, 0, 5. Okay. Now we have two spheres, the same radius, a bit boring, but now we can use our TouchDesigner favorite kind of things. Let's add music. Let's add music. Let's put it sorry, audio device sound. And let's use analyze RMS power. We add the filter. I don't know, half second would be enough. And I add a math here, and I add a null here. Okay. Let's say we want to change the radius of a sphere. It would be for the right channel, it would be for the left channel, accordingly to our music. Now we have radius 0.2, so maybe we multiply it by, I don't know, 4. Not 4 is too much, maybe 3. Let's try. Reference, check reference. And yeah, let's add a volume a bit. Well, it's not very exciting, of course, but I hope you get the ideas how we can use the Raymarching and the TouchDesigner, because here is example of music, but of course you can use any other kind of chop and data from anything to change the parameters here. And I don't know, you can somehow to drive color from the music, you can drive a camera from the music. Okay, let's do it. Let's another analyze. It would be, I don't know, sum. Let's add the math. Let's combine channels. Okay, and we need the filter again, maybe a little bit bigger this time. And maybe multiply it by, I don't know, 10. Maybe and let's move our camera, for example. Not too much, maybe 15. Why is that? Oh, because it's too much. Yeah. And also it could be interesting to show you here. If I increase the value, for example 50, at some point it could be too far away. Let's pause here. And maybe it's because our max distance for Raymarching set as just 20. And this means that after we reach the 20 units, our Raymarcher say, okay, I give up, I think there is nothing here, and so it renders empty space. But if I increase to 200, for example, I can see my spheres are far away. So sometimes you need to change max distance, sometimes you need to change the steps or minimum distance. But also keep in mind that it's not a good idea to set a huge distance and huge steps, because it will decrease your frame rate. It wouldn't decrease your frame rate 100 times, but it will decrease a little bit, because for every step and for every distance, the Raymarcher will need to calculate our distance from a sphere, so it's more and more calculation. And actually, in my GitHub I also have this SDF tests store. SDF tests. Okay, let me run it. SDF tests. It's my little tool for comparing different Raymarching technique, different parameters. For example, oh, by the way, mic code. Let's okay, I can't remember now. Okay. What is this tool? For example, here I have a Raymarching, and this tool show you the FPS, the GPU cook time, and CPU cook time. And it's really helpful to see, for example, okay, I have a max distance for 11, for example, I increase it to 20, and let's see, okay, we have a little bit FPS drop, a little increased time. Let's change our minimum. Okay, now we're better, but the result is a bit clunkier, and so on and so on. And as well, you can also compare two different Raymarching code from two different repositories, or compare anything you want. Or for example, you can add the second or third light and to check how more computational difficult it would be. It's really good for testing. Maybe it would be helpful for you as well. Okay, let's back. Okay, here's my example for the basic Raymarching. I call it basic because everything I described in this vectors page and this code here. And this is really good for most of the scenes, simple scenes. But sometimes you want to have, let's say, a lot of objects. And let's move to third container called texture buffer loop. In GLSL, in TouchDesigner, we have arrays page where you can pass a chop. And for every sample of this chop, now I have 10 samples, you can use in your GLSL code every sample in a loop. And it could be helpful for create, for example here, 10 spheres. The one thing you should know is that this chop at maximum can have only 4 channels, because in GLSL we have maximum VEC4 format. If you need more, you add another array, another array, another array. And also keep in mind that you should, by default it's array type is set as uniform array, but you need to use texture buffer. If I set again to uniform array, it wouldn't be working. So texture buffer, put my chop here, and set any name for this uniform, for example uprim. And let's look into our code. When I have use array, I need to define it as a uniform sample buffer and our name uprim. And also you need to give a number of samples in our array. And here I have on vector 1 page my uniform called unum. Actually it's fed from this chop with parameters. I have number of primitives, I have a smooth coefficient here, math, max and minimum distance, steps, and so on. And I can set, for example, 20, and if I say 20, I get this number 20, and it also create a top for me with resolution of 20. It not necessarily should be in the top. It could be just a noise chop, but I like to work in top context because, for example, now we have RGB for X, Y, and Z position, and you can use a level top for moving, for example, moving it in any direction. And you can use the math top for setting the value. So usually in the top the values is between 0 and 1, but I set from 0 to 1 to range into -3 to 3. So it's a position from -3 to 3 units. And for a scale I use alpha channel, and I have a separate math function, and I set a scale for my spheres here. I can change it to, let's some ridiculously high number, or maybe not so ridiculously high. Okay. Or ridiculously slow. Ridiculously low. How it works? How it works? It works like this. Again, we have our helper function about sphere. It's a new one. It's the plane. It's create a plane, a floor, let's say. I can get rid of it. I can start from empty scene if you want. Yeah. So now we have only these spheres. So we have a loop. A loop starting from zero sample, from sample number 0 until we reach unum, which is our sample number. And every step we will add 1. And we use a TouchDesigner fetch buffer function for sampling our data. What this does, it creates a vec4 which takes this color RGBA color for this particular sample in a loop. And we use RGB or XYZ for the position. I can change it to RGB, but I also need to change it here as well. And it works absolutely the same. So we use RGB value for the position of a sphere, and the alpha channel for the radius. It's a float. And we're creating our sphere in... yeah, it's a little bit different function, but actually it's the same. It's original, the central space, the central point of a space, minus current position, and minus radius. So we're creating our sphere in this position with this radius, and then we union our scene with the created sphere. So every time we go through a loop, we add to union one more sphere, one more sphere, one more sphere, and so on. And in the end, after we reach how much? After we reach 20, we return our scene. And again, good. On a GitHub, we have template for array, and let's try to do something like this. This is template array. Okay, let's for example use not spheres, but let's use capsules, and I show you one trick here. Okay, it's also interesting. We have two capsules, and you need to figure out what's the difference between these capsules. I checked it, and I know this capsules that define with the position, the height, and the radius. And this one formula, it's a capsule defined by position, the central position for the one end of the capsule, position for the second end of the capsule, and the radius. And I prefer to use this one. So we copy paste this capsule, and we already have the function for union. So instead of spheres, let's create capsules. I already have they fetched our sample. Okay, we fetched our sample. Let me think a little bit. What would we need to do here? In this value we have only x, y, and z. So let's use the two samples for defining a capsule. Let's use the first sample for creating one end of a capsule, and the second for creating second end of a capsule. So how can we do it? Let's say it's sample 1, and the sample 2 would be the same, but not for the current sample, but the sample plus 1. And let's create the okay, we don't okay, and we have end 1 of a capsule as a sample 1 RGB. We will define end 2 of a capsule as a sample 2 RGB, but we need only one radius, and this one radius, it would be, doesn't matter for a sample 1, for example. So instead of creating a sphere, we're creating a sample. So we need position, we need okay, let's copy paste it. It can be simple. We need a position, then we need one end of a capsule, second end of a capsule, and a radius. it would be not scale but radius. You can change it to rad. Change it to rad. And again smooth union. This. The difference here is that we use already two samples. Okay, let me run it right now. Okay, I have error. Undefined variable went to I mistype line number. Okay, here. Let's reduce our smooth radius. As you can see, we have some mess here. Okay, and also let's move a little bit away. Let's move a little bit away. And now our capsules start to disappear, so we need to increase the maximum distance. Let's increase it to 50. Oh, okay, maybe it's not enough. Let's increase to 100. And our capsule is connected now. Why is it? That's because every step we go into the next sample. And if we go to the next sample, so the beginning, the one end of a capsule would be the same as the second end of a previous capsule. So what we can do instead, if then we set our step not as 1 but as 2. So every loop we will add a 2. So we will jump from sample 1 to sample 3 to sample 5 and so on. And now we have a better, but of course it's not enough. Let me show it to you. Let's increase number to 40. We need to disperse it a little bit more, so it's from 7 to 7, and our scale is too big, so it would be from 0.1 to 0.4, for example. Well, maybe it's too small. From 0.2 to, let's say, 7. And again we can use something, I don't know, let's use just noise. Noise, where are you? Here. Noise, time sliced noise. We add the math. And the range from -1 to 1 to 0.1 until, let's say, 0.9. And let's feed it as a smooth distance, smooth coefficient. Okay, not so much going on, so let's change it to 3. So now it's our capsules unions with different smooth parameter. So I hope you understand how to work with arrays as well. Okay, what's next? I think that's it. Yeah, I think for this first part of a tutorial it's already about 1 hour, maybe a little bit more, so that's enough. And if you like my tutorials, you can support me on Patreon if you want, and see you next time. I don't know where would be a next part of a tutorial, but I hope it would be not too late, maybe in a couple of weeks or maybe in a month. And thank you. Experiment with Raymarching and post your results somewhere and keep in contact. And you can contact me in Instagram or on GitHub, or you can support me on Patreon and post comments here. And on Patreon I would also put several bonuses for supporters. It would be, I don't know, one example of how to use the noise function for creating a noise instead of primitives, and another one would be how to use the Raymarching with the Kinect. Okay, see you, bye.